and welcome everybody. We just watched a very interesting video. My name is Ryan McEachern. I'm the Managing Director of the Mining Suppliers Trade Association of Canada, and it's my pleasure to have Cal Ruberg here, VP Future and Chief Innovation Officer of Teck Resources. So to jump right into it, Cal, let's talk a little bit about this video we were just watching.
Well, Ryan, it's a pleasure to be here, and good morning, Australia. Yeah, is this science fiction or science fact? And I think many mining companies are really struggling with how do we get to zero GHGs by 2050? How do we get a true reduction by 2030? We're all experimenting with different ways of doing it, using hydrogen in trucks, using battery-powered trucks. So how do we really get there? And one of the real issues is that we can't keep on doing what we're doing, one way or another. And even the size of the trucks, the way we mine planning, and generally the way that we approach, in this case haul processing and logistics, is not going to be the same. And so we have to move from science fiction to science fact. In that video, you saw 15-ton trucks. And so instead of 76 ultra-class trucks, we would have 1,200 15-ton trucks.
Wow.
And these 1,200 trucks would be just scurrying around the mine, basically completely autonomously, like ants, using swarm technology for dispatch. You wouldn't be dispatching centrally. And in fact, you would be loading these trains of very small vehicles, battery-powered vehicles. They would be constantly being regenerated, coming down, and then re-energized on pads, or batteries being replaced depending upon the strategy. These trucks don't actually exist commercially yet, but they are being developed by various OEMs, and the technology to actually guide them is also being tried out. But critical to all of this is because ultra-class trucks last forever. Essentially, they're assets in these huge mines. How do you actually plan for a GHG future that is literally only 25 years away at best? And so if we're buying large autonomous vehicles at this point in time, how do you actually introduce a zero GHG fleet that might have a very different character, a very different way of actually being used in a mine?
Well, and you brought up a very interesting point. Our theme of our dialogue is about digital transformation and the technology there, but really it's closely tied to the GHG footprint narrative, if you will. And what you saw there was a real transformation in terms of how we're going to look at managing our processes and all the technology. And so my thought to this is, I think AI, machine learning, all these components seem to be integral to them in terms of platforms and stuff. But what do you think is going to be the biggest impact in terms of this digital transformation?
Oh, I think certainly any AI technologies are really creating a big difference in the way we are approaching our mining. And also communications technology is making an enormous difference in not only the instrumentation that we use on trucks, but instrumentation in process technologies. The underlying telecommunications capabilities and computational capabilities in the cloud are changing the way we actually build architectures now. But they're also changing the way that companies interact. So just like you said, it's not one thing anymore. It really is a system of systems. And it's not only a system of technology, it's a system of companies acting together to get things done. And you brought up a really good point on AI. Machine learning is a great example of sort of what Teck has been doing for many years now, so about 5-6 years. And one of the things that really comes up is that people say, well, just apply machine learning, right? Oh yeah, it's not a problem. I mean, the machine will learn and the problem will be solved. And it's not quite so simple. Machine learning takes tremendous, unbelievable amounts of data. and to actually achieve the levels of data you need to do, for example, predictive maintenance on a specific class of haul trucks or type of haul truck, because it can be very specific, and it should be very specific for machines to learn predictive maintenance, then a small company can't do it because they will never have enough failures to actually learn. A large company might be able to do it if their fleet is fairly homogeneous and fairly unique in type. But if you think about it, then actually you can only do it by collaborating with other mining companies to get enough data to actually build the machine learning capabilities to predictively maintain large fleets. And so, I think that collaboration on these levels of data and data analysis are absolutely critical between mining companies at this point in time. And METS plays a very big part in that, right? So all of the companies actually play a huge part in that.
Okay. And before we get you're using a key word, I think, in this conversation too, is collaboration. But before we go there, I think there's a big disruptive aspect to this whole digital transformation that has to be kind of looked at. And so, and what I'm getting to is kind of a change in the manpower or people power, I should be saying. What are your thoughts on that? Because this is going to really change the workforce of the future, I believe.
Right, and you're absolutely right. I had a really great opportunity to visit Baosteel in China 2 years ago now, and they have a mile-long rolling steel mill. And on the floor of that steel mill, there were 4 people. It's a mile long, 4 people on the entire manufacturing floor, and they were actually maintaining a router.
They weren't even operating.
They were not operating a machine. They were not, managing the machine. They have a centralized control room where they actually run the plant. And more miners are beginning to look at integrated operations. We have our integrated operations center at our new project in QB2 in Chile, in Santiago. And so what it does is it actually takes people out of dangerous situations and very debilitating situations. The QB2 mine is at 4,400 meters. We're actually going to be operating most of that process from Santiago. It gives people a quality of life and a quality of work that can't be actually achieved at the mine. And so I think that we're removing people from harm's way. In Europe, these regulations are becoming very stringent. And actually forcing miners to look at how do we mine without people at the mine face. We're certainly nowhere near that, but I think that we have to, as an industry, begin to think about, well, how are we going to engage communities and engage workers in our industry? And it's not that there isn't a shortage of workers in our industry, because there is, and there's predicted to be an even bigger shortage. But how do we actually begin to work with governments and with academia to really engage, the coming workforce into areas where this is a requirement? I mean, you saw in the video there weren't a lot of people involved. I mean, some shovel operator was still there. Very, very complex set of work there, but not a lot of other people. And it's a changing world.
Right, and that's what I kind of saw in the video too, and I've seen in other dialogues is the people managing these, and I see it from an operations standpoint, the actual people that traditionally are operating these equipment is going to reduce as well, because you'll have one person being able to operate multiple pieces of equipment, especially if the process is sequential. They can basically push a button and start operating the next piece of equipment, and vice versa, and so on down the road. And then with all this fleet of, I'm assuming this is considered this future, these are autonomous units. So you're really kind of monitoring as they go. If I can ask the question, what I'll put in my assumption, then you can comment on it. I foresee the future workforce on the site to be more support and less operations. And so you're seeing maintenance and technicians as opposed to the frontline worker. Is that a correct assumption?
Well, I think that that's where it's pointing to at this point in time. That there will be far more maintenance and support folks, but I think that that's still very unclear. There are still very many decisions that have to be taken on site, and I think that the whole notion of what's changing here, and the transformation, the basis of this transformation is actually changing mining from mining, which is almost a very industrial age type of activity, to a manufacturing or an industry 4.0 or even an industry 6.0 type of endeavor, and that's a huge change. And the reason why mining has been slow to adopt a lot of the manufacturing capabilities of reducing unplanned work, lean manufacturing principles in the whole value chain from pit to port, is that the variability of the source material is so great. So once you blast, you get a lot of mixture of materials. You have you can only discriminate at a sort of a block level, which is actually a very large amount of material. And that leads to variability. That leads to a lot of WIP in the system, a lot of work in progress, a lot of stockpiling in the system to absorb variability. And so the variability, the reduction of variability is actually this business transformation in a lot of ways. But it's very, very hard to achieve in mining because the source material itself is fairly variable. Once we begin to once you have sensors and once you have a very good characterization of that material, it may become possible to actually selectively extract that ore or extract that coal in a way that is far, far less destructive, first of all, to the environment, but second of all, is far, far more efficient in terms of processing, production, and then actually sales. And so, there are so many interrelated pieces in this whole chain that any one thing, any one process will not lead to a state of solution, if you will. And so this whole thing actually has to be looked at as a system and modeled as a system. And many approaches to machine learning are still looking at one process at a time.
Right.
And that actually doesn't get to the answer.
And I think this is a good way to kind of like direct our conversation to the suppliers of solutions and products and services. And you brought up the term of collaboration. I've said in the past, if your product or service isn't communicating, it should in the future, because you mentioned the term sensors, and so collaboration, that kind of autonomous communication, self-diagnosis of products and services. What are your thoughts on that?
Well, I think they're becoming, more and more standards are emerging. I think organizations like the GMG, like many of the national organizations on mining, really are helping to standardize those approaches for the mining technology providers. So architectures are becoming, shall we say, more standardized as well. The notion of an API and the notion of a perhaps a standard semantic set of vocabulary that is used to describe the process is really beginning to emerge, albeit slowly. But again, almost all the providers have some measure of API that they would connect to systems, either on the back end, that is from a data pipeline point of view, from the sensors, from the historians, all the way through to some layer that the companies own, or even that the providers provide themselves. And so I think that it becomes a really interesting architectural issue at this point in time, whether you become a vertical purveyor of the entire solution, like an MRP system for mining, or whether you actually begin to build very unique solutions that can then be plugged into a system of solutions. And open systems is certainly one area where that would be really helpful if we all actually understood what some of those API requirements were, both on the presentation side for people to look at and control, as well as from the pipeline side and data to control both ways.
Right, right. And a bit of that's tied to the concept of maybe open platforms as well, right? In the sharing of information. And you mentioned it, a systems approach where not getting or being aware of your point solution as tied to a larger system and how does it fit into that. And so you kind of have addressed that. We're getting some questions and we've got a little bit of time, so I'm gonna try and delve into some of them. Here's one question for you, Cal. In places like Canada, employment job creation is a big part of successful operations, looking at public opinion. Couple that with zero emissions push, is there such a thing as a project running too autonomous? What is a good balance regarding safety, emission reductions, and economic recovery, i.e. jobs? Good question.
Well, it is the question, right? How do you balance that? And so one approach that we've really begun to use is making sure that as we begin to change out the workforce, or as there's a potential to change out the workforce, and we're not changing the workforce in any significant way right now. How do you actually manage the change of guard, if you will, from the current situation to a new situation? And we have a number of different programs in Canada, including some of our supercluster programs across all the provinces, but particularly in BC. We've actually got a number of different projects on the go with academia in terms of getting younger interns, more diverse population of interns into these particular roles, and that's actually worked very, very well for us. And
right. And I think it's as we see the removal of certain responsibilities or jobs, you're going to see addition of different types of jobs. And
correct.
So that's
the
other
right.
piece.
And it's not a net reduction so much as a net change, and a net change in place of where we're doing this, and a net change in the type of work. Just noticing the amount of operational support that these systems requires goes up, and so it doesn't go down. I think that all of these systems rely on being maintained at a level that hasn't, that current analog systems, if you will, like large mining apparatus or assets, don't really require it. So, it's a different mode of operation. Manufacturing is very precise, and the precision, it reduces variability. And so again, it's just a change. And that transformation is going to take a while, and it's going to be pretty interesting journey.
Yeah, exactly. We've got just over a minute here, so I'm just going to throw this one question at you here. How
Sure.
big a role is hydrogen playing in mine energy?
Oh boy, this is my favorite topic, right? So, hydrogen is not an energy source. Hydrogen is an energy, basically a battery. That's all it is. And so, hold on, is a battery. So, in order to create the hydrogen, you need a source, and you need a green source. And so in BC, we're very fortunate. In Norway, they're very fortunate. In Switzerland, they might be fortunate with hydro. But elsewhere in the world, they are going to have to figure out, how to get the hydrogen actually made. And so that's going to be a real trick. And nuclear, you say the word and everybody, of course, runs into the corners. It has progressed an awful long way in terms of very, very, very small batteries, actually. They're called nuclear batteries. But that's a very interesting, the whole politics around hydrogen is also very interesting. So.
Right. Well, with this few seconds left to go here, I'm going to thank you very much for taking the time, Cal. It's been a real pleasure having this conversation with you. Thanks for being
Ryan,
here.
yeah, no, it was my pleasure. Thank you.
Take care.
Bye.
Whether high up or deep down, for your work, you need strong equipment and smart solutions for all kinds of challenges, starting from basic products to essential components, and up to intelligent technologies. Developments are shaping the way you handle operations. The future of your industry holds exciting innovations. Let us show you the possibilities. Doesn't matter where you work. Team up with us for your success.